we have a tree, okay, and it casts. Casts mean makes, okay. So a tree makes a shadow, which means it's definitely the sun is out, okay, a shadow, and the shadow of the tree is 22 feet long, okay. So that means the shadow of the tree right here. Obviously, where's the shadow? The shadow is beginning from the base of the tree all the way to this. By the way, this line, if you're interested in what it represents, this line basically represents the light coming from the sun. Okay? So apparently the sun is at an angle like that, and it's sending the light this way, such that the tree is actually, sorry, this is the tree, and it's making a shadow only this big. Okay? We're gonna put 22 right here. 22. Okay? All right. What else do we know? We know that a 6 foot tall lumberjack, someone who cuts trees, casts a shadow that is 8.5 feet long. Okay, so I guess so. He is 6 feet, while the shadow is 8.5. You see how the diagram is bad? This is 6 and this is 8.5. Doesn't make sense. The 8.5 should be what? Should be longer. Again, that's why you never trust diagrams. Just put numbers on. So I guess we're gonna put 6 here, and I guess somewhere in this small space, 8.5. Okay? What's the question asking? The question asking, using the fact that the triangles are similar. I know you're like, where are the triangles? Well, the triangles are right here. This one and this one. Using the fact that the triangles are similar, find the height of the tree. Round your answer to 1 decimal place. Okay, so one good practice to do now, instead of using these triangles right here, we can just sketch them again here. So everyone, let's do this. So let's sketch a triangle right here, and a smaller similar one right here. Does anyone need rulers? Anyone? Your diagram doesn't have to be perfect. Okay, even if your lines are not super straight, that's absolutely fine. Anyone? Okay, I'm glad that so many people are not using them. That's fine. Okay, so what do we need to do now? Well, you can start by putting numbers on, or you can start by labeling, or you can start by putting the symbols for the angles. Either way, you pretty much have to do almost all of that. So let's actually do what? Let's do the labeling. A, B, C. I guess we're going to go with X. Sorry, don't make it a small x, make it look like a capital X. So X, no curve. Y, Z. Okay, everyone, what do you think this angle should really be? I mean, usually when a tree grows, does it grow tilted or straight up? Which means, what's this angle? What's the angle? What should the angle be? Yep, 90 degrees. We're assuming, just like when you build a wall, for example, you don't want it tilted. So we're going to assume that this, everyone, here, right here, is 90 degrees. So we're going to put 90 here and 90 here. Okay, so that's the first thing. Okay, so we know that two angles now are equal. Where are the two other angles are equal? Well, definitely the angles at the top. Definitely the angles at the top. Why? Because the light from the sun is hitting both exactly the same way. So that means this angle and this angle are the same. So I'm going to put a small circle, a small circle. Okay? By the way, I just realized something. That small circle, everyone, does not mean degrees, because it look like the symbol for degrees, like 45 degrees or 90 degrees or whatever. No, it's just a circle. This has nothing to do with the fact that I know what it is in degrees. I actually don't know. I have no idea what this is in degrees. Which means we're only left now with one symbol, which is the square or the diamond or whatever, or even you can put a star. I think it's easier to put a box. Perfect. Okay, what's the last thing to add to this? The numbers that we know. So obviously this is the longer one, so it's the tree. So this is 22. Yes, go ahead. Yeah, go ahead. Oh, I'm about to do that. You're absolutely right. I'm just putting the numbers I know first. You see, I always like to put the numbers I know first and then see what I'm trying to find. Perfect. So what else do we know? We know that the small triangle has this to be 8.5, so 8.5 here. And we know that this one is 6. So Faisal, where do you put the small x as the variable you want to find? Exactly. We are trying to find this one. Everyone put a question mark there. Put a question mark next to the tree. Next to the tree. We never put question marks on triangles. Well, we can, but it's always better to put what to put the symbol of the thing. Yes, the symbol of the thing we're trying to find. Great. Okay, now we're ready to do what? The similarity statement. Okay, so I'm just going to zoom in so everyone can see. I'm going to go down, and we have this space to write. Okay, so triangle A, B, C, A, B, C is similar to, obviously, X, Y, Z. Don't forget the triangle symbol. X, Y, Z. By the way, for the quiz I'm going to give you next week, which will have to do with what similar triangles, if someone forgets this in their quiz, for the first quiz only, I'm not going to take marks off because I understand that you're trying to tell me that triangle ABC is similar to triangle XYZ. But once you have a second quiz or a test or so on, it will count for half a mark lost in your statement. Okay, so make sure you put the triangle symbol. Okay, now let's do this at the ratios. Ratio, ratio, ratio. Okay, what ratios do I have? Well, I have AB corresponds with what? XY. I have BC corresponds with YZ. And I have AC corresponds with XZ. Okay, perfect. What's my next step? Again, by the way, now I'm repeating exactly my work from yesterday. Who remembers what we did after this step from yesterday? Put everything that you know down or whatever question mark. So I'm going to go with green. So do I know how long AB is? No, AB. I don't know where it is, but I know I want to find it. So I'm going to put X. How about XY? Yes, I do. It's the height of the person, so it's 6. How about BC? 22. How about YZ? 8.5 or 8.5. Can you stop here? In my course, yes, you can. However, if you want to keep going, you can just put question mark here and question mark here because you have no idea what they are. Exactly. So one other thing you can do is, everyone, I'm not going to do this today, but I did it yesterday. You can circle this one. And Faisal, what did you say? Useless because it's completely of no benefit to us. We cannot use it and we don't even need to use it. So you know what? I'm just going to not put anything. The fact that it has 2 question marks means you can't use it. All right? Follows now. Let's put the numbers in. So I have x over 6 equals 22 over 8.5. What do you always do when you get to a step like this? What's the process name? Cross multiplication. Cross multiplication. So cross. Okay. So 8.5 x's equals, okay, I need, let me just, 132. So let's take 22 times 6, 132. Perfect. Yes, sure. That's it. We're almost done. What's my final step? By the way, again, remember, feel free to write things on the same line. But everyone, just so you know, listen up. This is a very common mistake, even up to grade 12. Many people do this. Look, don't write this down. Instead of an arrow, they do this. Is this correct? It's not incorrect to put multiple equal signs on the same line. I'm fine with that. It's incorrect to say that 8.5x is equal to 32 is equal to x. No, This is not equal. You have to put what here? You have to put what? Yes, it's not equal to, but the step leads to it. So you either put an arrow like this. By the way, this is a very common implication arrow, like implies or leads to. Or you can do an arrow with what? With a single line like this. I don't care. Just do not put equal all the time because it's not correct. So x equals that. How much? Now let's actually just see the rounding. Sorry, divided by 8.5. Okay, what's the rounding situation as far as the question is concerned? It's saying what? One decimal, not one whole number, one decimal place. So that means I have to cut. I have to cut right here. So does the 5 change or no? Nope. So what's the final answer? 15 and a half feet. 15.5 feet. Sorry, let me just move it. There we go. 15.5 feet. So apparently, this is, by the way, this is the height of the what? The lumberjack or the tree? Well, first of all, no one is 15.5 feet tall. So this is the height of the what? Of the tree. Do you need a therefore statement? Not in my course. The fact that you showed me all this work and you labeled and you used the diagram well means you exactly know what this represents. It represents this question mark. Done. That's it. So you see, this is exactly like yesterday. You just had to make sense of the word problem first. Okay, let's look at the second problem. Just going to zoom out so you can see the whole thing. Okay, second problem. What's going on here? Okay, so we have, let me just zoom in. Yes, exactly. We have, many of you definitely noticed this one. The fact that they are joined in one point, everyone, the fact that they are joined in one point right here means that the Z exists. Okay, so, but what's the problem saying? To calculate the length of a pond, a body of water, so the distance between A and B. So basically, from here, sorry, from here to here, okay, what happens? A surveyor, someone with basically a kind of a something like a tripod and a camera. It's actually not a camera. It's like a laser beam. Measures distances very accurately, sometimes even to the millimeter. A surveyor takes some measurements. Okay, she produces the following diagram, sorry, shown on the right. Using the fact that both triangles are similar, and obviously those two lines are what? What do you call two lines that never meet? Parallel. Find the distance AB, or find how wide the pond is. Round your answer to one decimal place again. Again, I'm either going to ask you for one decimal or two decimals. Okay, so I mean, we could repeat, honestly, we could repeat the what? We could repeat the diagram again, but do we need to? I don't think so. This looks like a good diagram, so let's keep using it. Okay, do we have everything labeled? Okay, so no need for labeling. We need to know which angles are the same, though. Okay, obviously, this angle is how much? 90. This angle is how much? Perfect. Give me two other angles that are also equal. Remember, we did 4 theorems yesterday. The Z, the X, the F, the C. Which one should we use here? Shadi? B and yes. So if you use the Z, you know that this sharp edge is equal to this sharp edge. Where's the other two angles that must be equal then? Exactly. E itself. So E on this side is equal to E on this side. Because of the what? Because of the X theorem. So go ahead and put, to the best of your ability, maybe like a circle here, and a circle here, and maybe a star here, a small star. I know I might not have given you enough space. Okay, don't worry. On tests and stuff, I'll give you big diagrams to really be easy to label. Great. Oh, what else do I need to indicate? I need to tell myself that the Z is perfect. So that means I need to indicate that those two lines are what? Those two lines are what? They have to be what? You have to be parallel. If they're not parallel, by the way, if someone shows you this diagram, can you say that this angle is equal to this angle? No way. Impossible. I mean, look at this one. This looks like almost a 90 degrees, and this is looking acute. Remember, these two have to be what? Parallel. Thank you. Otherwise, the Z is not even a Z. Well, not a perfect Z. So I'm going to put an arrow here like this. You don't have to put two arrows. I know I usually put two. Doesn't have to be. Just put the same number of arrows on each. Perfect. Now we're ready to do the what? The statement. So let's look at the statement. Okay. Can someone tell me what could I name my first triangle, or what is my first triangle? Yeah, Shadi. A, B, E. Okay, so we're gonna go with that naming or that ordering. Triangle A, B, E is similar to triangle. Okay. If you're going A, B, E, how do you start the other one? A matches with C, B matches with D, and E is what? Is exact. E here is E here. So there's no need to use what? Two different symbols. So triangle what? Triangle C, D, and E. Perfect. On to the fractions. Fraction, fraction, fraction. Okay. What numbers do we know? Oh, sorry. Before the numbers, we have to put the symbols. My bad. So yes, go ahead. AB. So let's go with AB over CD. And then I'm going to go, what do you want? Sure, BE with over DE. And finally, AE. Thank you. Okay. That's another good C. That's a good C. Okay. How long is AB? I don't know. I need to find it out. So everyone, go ahead and put question mark here, which means we have to put X here. Okay. How long is CD? CD. 16.2. How long is BE? We don't know. Question mark. We don't know, and we don't want to find out. So it's not even another X. It's a question mark. DE. Again, not known, not needed. All right. I guess we found our useless fraction. AE from here to here. 18.6. And this small one is 3.6. Beautiful. All right. On to the math. So I guess we're going to do this equals that. So I guess we're going to take these two and these two. Cross, cross. See, this is I use this to tell that this step leads to something here. Okay. Yes, Shadi? Which one? The green? So so if you okay, like the very, very, very final answer? Oh, maybe it's just the multiplication step, maybe? Yeah. Yep. 100% okay with that. Yes. Oh, I'm not sure if I mentioned that before. Everyone, listen up. I think I did. Maybe not with you, maybe with the physics people. Do you ever have to show me the cross multiplication sign when you're doing Google form? No, remember, you can't. All you have to do, everyone, all you have to do when you get to here, actually, I'll show you how to do it. Everyone, just eyes up here. So let's say, everyone, listen up. Hamza. So everyone, let's say you're trying to, you're trying to put this on the Google form. Could not be easier. On the Google form, just do something like this. Where's the x over 16.2, sorry, 0.2 equals, what is it? 18.6 over 3.6. Okay? Your next step should not be doing this. Your next step should just be what? This times that. So what do you do after that step? Nothing. You just write 3.6. 3.6x equals, can someone do 18.6 times 16.2 for me? 83.7. Okay, so let me just, keep going with that. So 3.6x So to Shadi's question, if you skip from here to here, that's fine. Sorry, what was it? 83.7. What's your next step? Oh, that's the final answer. Oh, no, no. Okay, I just need. Yeah, you're right. You're right. 18.6 times 16.2 is like the 300. Yeah, 300 what? Oh, thank you. And then your final step is x equals 30132 divided by 3.6. And you said the final answer was what? Yeah, you're right, in meters. So obviously, your next step should be, my bad, so 301, 32, and then x equals 301.32 slash 3.6. And you can go on the same line. I really don't have a problem with that. Boom, that's it. So you never need to show me visually the cross multiplication. Show me what it means. This is what the cross multiplication leads to. And that's it. There we go. So this is how wide or how big the pond is. Okay, so I'm just going to zoom out. There we go. How many people got the answer 83.7? Like how many people actually? Perfect. Okay, thank you. I just want to know what's the actual 301.32 divided by 3.6. Oh, no rounding even. Wow, that was weird. Okay. All right. Clear. Okay. So I hope so far the idea of similar triangle is sinking in. It's the same process. You just have to what? Translate the word problem into what? Into this. Okay, everyone. Pencils down now. Let's look at the last one. The last one is always the hardest. Why? Because the triangles are not just touching. One of them is completely what? Inside, absorbed in the what? In the bigger one. Okay, let's just look at the problem. So the problem is saying, what if one triangle was inside? Sorry, what if one triangle was inside the other one? Basically, just like this situation. Okay, we need to find x. Can someone tell me where x is? It's the what? By the way, what do you call the bottom part of a triangle? Well, the bottom part of is what? Is the base. By the way, when we do areas for triangles, what's the area? Does anyone know the equation for the area of any triangle? Base times height divided by, there you go. So base and height. Perfect. So first of all, can you tell me something special about those two lines? What do you think they are? They have to be. Otherwise, I can't give you this problem. If you made this line crooked, like tilted, this triangle and the big one, no, they're not going to be the same. Okay? Or sorry, similar. So the first thing we have to do is to indicate that one of them is parallel to the other. So go ahead and put parallel, parallel. Okay. I'm going to do this problem, everyone, by doing one simple but very helpful thing. I'm going to take the small triangle. What? Yes. Okay. So let's pull the triangle out of the big triangle. That generates how many? That will make us put how many triangles? Two triangles completely what separate of each other. So basically, we are going to repeat this problem. Everyone, we're going to repeat this problem. Okay. So let's do that. Oh, by the way, hold on. Let me just see something. Oh, okay. Fine. All right. So let's take out the triangle. Well, I'm gonna do my best to try to what? Repeat this shape somewhere here. Okay. It doesn't really have to be perfect. Whatever I can do. So this, this, and that. Yeah, I think it looks okay. And now I have to sketch what? The big one. So I'm gonna try just to sketch this one bigger. So I guess I'm just gonna. By the way, do we have more space here? Let me just see. Can I just see your? Okay. I mean, everyone, you can either do them here or you can do them here. It's up to you, whatever you can fit. I'll see if I can fit a slightly bigger triangle on this side. I need to look this way. Nope, needs to be the same. What's up? I have to group it first and so on. Probably it's gonna be easier this way. But you're right. I can copy, and then what? And then, as you say, enlarge it. You're right. Microsoft Word can do that for sure. Okay, everyone, this is good enough. This is good enough. Okay, let's put some numbers in. Can someone tell me what numbers do we know about the small triangle? Just the small triangle. Shadi, give me all the things that you know about it. We know the base is how long? Sorry, 3.4. And this part is just what? All right, go for it. Okay. What do I know about the? Yes, sure. Go ahead. What do you know about the big triangle? Anyone other than Shadi? He got so many chances today. Hamza, go for it. The base is what? Just x. So hold on 1 second. Base is x. Well, you mean this whole leg? How much? Patrick? Thank you. Is it just this part? Can you ever look at a part of a triangle? No, you have to look at the what? The whole side of the triangle. How long is this whole thing? 3.1 plus what? Because remember, it's as if this one doesn't exist anymore. So it's the whole thing. That's the main trick in this question. So 3.1. I mean, you don't have to show me the addition. You can just show me the final answer. But I like to have this in my video. 1.5. How much? 4.6. Awesome. It went from two triangles inside of each other, or one inside the other, to just what? Two split. That's gonna make it much easier to what? To do. All right. What's my next step? I don't. Do I even need to look at this anymore? Nope. It's been completely like replicated into here. Okay. What do I do? A, A, B, C. Yes. Label. So A, B, C, X, Y, Z, Z. Okay. Which angles are the same, everyone? Look at the big. Look at this triangle. Are those two angles the same? Yes. Why? Because those two lines are what? Parallel, and this one line cuts them. So this street intersection is the same as this street intersection. So go ahead and just put what? A star here and a star here. Okay. Which other two angles are the same? The complete opposite side for the same reason. This intersection of the streets is the same as this intersection of the street because this is the same street and those two are parallel. So I'm gonna put. I don't need those green lines. Oh, let's go with the whatever small circle. Small circle. Which angle is common between the two? Okay, I'm gonna repeat them here. Absolutely. No, no. But I wanted to use the fact that they're parallel to prove they are the same. That's all. Which angle is shared? The top one. So let's put a box, I guess, or a diamond or whatever. Awesome. And now I'm gonna put the same thing. Diamond, diamond, star, star, and I think we did open circle. Yes. Open circle, open circle. Okay. And the rest is what we do every time. Pleasure. So triangle A, B, C, is similar to, yep, X, Y, Z. All right. Ratios. Mm, mm. AB is XY. BC is YZ. And AC is XZ. Okay. What do we know? Do I know AB? Do I know XY? Both are not needed. Sorry, both are not known and also not needed. Question mark, question mark. Hey, I know my useless one. Okay. BC is 3.4. YZ is the unknown but to be found X. AC 3.1. XZ is the whole thing as we proved, so it's 4.6. Perfect. So, as Shadi said, you can skip what I'm going to do right now into the cross multiplication step, but I'm going to show the fractions. I have 3.4, so I'm going to basically do these two fractions. 3.4 over x equaling 3.1 over 4.6. Res, Ras, Res, Ras. I get 3.1 x's. All right. What do I have? 3.4 times 3.6. 3.4, 4.6, 15.64. And then that leads to a final answer of x equals 1564. Now, what is the rounding situation? 1? Really? All of them? Oh, did I say? I didn't say. So how do you decide? Look at all the numbers that we have. What numbers do we have? We have 3.1 with one decimal, 3.4 with one decimal, 1.5 with one decimal, which means what? You also keep it to the same idea, one decimal. Oh, my bad. Does the 4 change or keep the same? Does the 4 change anything before it? So what's the final answer? 5.0. Do we have units? Feet indeed.